Okay, can you guys see my screen? Can,
Yes.
right?
Yeah.
Yeah. So today I will be talking about my adventure in auditing the source engine code base. Firstly, I'm sorry if my English is bad. I haven't practiced a lot, but yeah, I hope I can still give a good presentation. Well, the adventure is not just auditing the code, but most of the time I after I submit the bug, I have to wait like half a year for a while to resolve my bugs. So yeah, well, let's get started. Let's get started. Um, to introduce about me, I'm a Vietnamese. I joined the C Group's security team in August. Yeah, back then I was a software engineer in Shopee. I'm a otaku or weeaboo, whatever you call me. I have a great love for idols. Uh, I have been researching and developing things related to Counter-Strike for 10 years. It's not a lie. I swear, yeah, it's not a lie. Mostly because I want to modify the games to introduce new game modes, new weapons, something like that. Uh, well, then I am interested in finding vulnerabilities. After that, yeah, my CS:GO rank is Nova. I'm a noob. Yeah, and as we just talked before, I just won something in Pontoon Austin 2021 in the router category. Next up, I will be introducing some information on the SOC engine. It's the proprietary game engine of Valve software, which were released in June 2004. The first game, I believe it was Half-Life Source and Half-Life 2. Yeah. And after that, there was Counter-Strike Short, Team Fortress 2, Portal 2, Left 4 Dead, and most recently, CSGO, Dota, and Half-Life Alyx. While as before, as the same as the Roadsock, which is the engine for Half-Life and Counter-Strike 1.6, they gave away the SDK available for free, so that people can make new games based on the engine. And the engine is still ongoing active development at the moment. So why do I choose it? Well, I started my programming career with modifying the Counter-Strike 1.6 game by coding things to add new game modes, new weapons, and change the game mechanics. And since I already have the experience with the GoSock engine, they have the SOC engine and GoSock engine. They have a lot of they share a lot of principle, like how the networking code work, how the files are loaded, how the client and server communicate. And yeah, apart from SDK, I think some of you guys may already know the full engine code of the SOC engine got leaked multiple times, even before it was released. And up until the last year, a recent version of the code base got leaked on 4chan. If I remember correctly, it was the 2017 version of the engine, and it helps a lot with finding vulnerabilities in CSGO because the code is more recent. I don't have to filter all bugs. Well, the engine is written in C++, the code base, I have mixed feeling about this, but a lot of spaghetti code, a lot of things that even the engineer involved doesn't know what does this do or something. You guys can find a video about this on YouTube. Someone point out the comments inside the code base is pretty funny. And also, what attracted me at first is a bounty that Valve gave down. Like at 2018, they get out $10,000 for just for just a simple Stack Overflow. But now I think they still get big bounty, but now I think isn't simple like that anymore. So the next thing is we will talk about the engine itself. The engine uses a client server model to communicate. Normally, when you play a game, you connect to the server, and the server will do all the processing from player position, player health, damage, how the weapon fire, and collision. The server will do it for you, and client just predict the movement, everything. So you don't experience delay or lags between the client and the server. Also, the engine, not only networking, the engine also has some other subsystem like file system, model texture processor, physics, and audio processor. This diagram is oversimplified. I'm not gonna talk into detail for all of this for all of these subsystem because it will take a long time. And yeah, it actually takes me a long time to understand how the networking code works. Even now, I cannot say for sure that I can explain it in detail without looking at the code again. Well, for the methods that I use and tools that I use to audit the search engine code base, general method, I audit the source code for potential vulnerability. And then when I pinpoint a potential vulnerability, I use either or any disassembler like Vitra or Binja or something to verify that the vulnerability is still exists in current latest version of a game. The tool I use are pretty simple. I just use grep to grab potentially vulnerable pattern, and I use IDA for disassembling the binary. Of course, CodeQL, I thought about CodeQL before, but the free version cannot build the SDK because it's so big and it took a long time to build. For the paid version, I don't have money. And I think it's only available to enterprise. I never checked that yet. This show how you can just use some simple tool like bash or grep. No need to use like advanced tools to find vulnerabilities. Another method that other researchers do that I don't do is thirting. They for the file format, the network protocol, but yeah, I don't have any experience with thirting, but it's a good way to find bugs. Next up, some example of bugs that I found during my journey. First, I searched for unsafe function like sprintf, strcpy, or memcpy without any bounds check. Yeah, we can see here an example of sprintf with about checks and with %s on a stack variable. Well, because it is a stack variable, and we can do a stack overflow, build a rock chain to achieve code execution. Normally, when you do CTF challenges, other will enable stack canary, so you cannot just make the stacks. You have to lick the canary or something. But I think in every software that Valve use, they don't enable stack canary on Windows, even Steam, not only games. I don't know why they do this. A lot of bug has been found and reported to the program as stack-based overflow like this. I don't even know why they still haven't enabled it. It will not. It really will not affect the performance of the software. This vulnerability is disclosed on HackerOne with the ID I give here. So just change it with an default and or use a non-ASLR module. You can get easy rope and achieve code execution. So that's just one thing. But even though Valve implemented their own string function wrappers to wrap unsafe function like S3 string and copy to correct new terminator string, some still fall through the crack. Like they use a variable that can be controlled by the attacker at the side of the string instead of using side of the buffer. Yeah, one famous example is the P90 Rusty challenge in real world CTF 2018. The Perfect Blue CTF team has a great write-up for this one. You guys can search it on Google. It's beautiful and a lot of details, and it might help you in knowing more about the code base. Yes, thank Junhua for the link in the chat. The next thing is the difference between debug build and release build. Normally, when debugging code, we will use a macro called assert to crash or trap the program with the debugger when something unexpected happened, like some condition got violated. In debug mode, the assert defined here, they define it as assert message, and it will trap the debugger when a condition get violated. But in release mode, it's defined to nothing. So essentially, no check on release mode. And yeah, you know what? The publicly released version of all the games and software, but they always release using the release mode. Well, then what does this mean? Just grab access and you get easy out of phone access like this one. This one is very famous among researchers in the search engine research community. We can see here it check the n num is greater or equal than 0, and it must be smaller than max edits. But as I said before, this is the release view, so these two lines are useless. Yeah, we can we can easily get an out-of-bound read at this point. The most amazing thing about this is this function was exploited by Ahmad Kama from 2017. He even gave a presentation at Insomni Hack 2017. Yeah, but in 2030, it turned out that while still haven't patched it, they only patched the caller. It's not a root. It's not really root cause. They will not fix it by patching the caller. The callee they still use the same code. Many more OOBs can be found by grabbing answers. I'm sure even now you guys can still easily get a crash by grabbing answers and build up easy pop without any info leak. An example of abusing the particular function is a 584603 report on HackerOne, but this is by another researcher. I report some bugs that I found using this method too, but they still haven't resolved it, so I cannot talk here. Wow. GG. The next example is a logic bug that I found. It's pretty lame, but but I think it's still worth mentioning here. Let's read the code first. We have two buffer here with size 256. Here we get the file name here. The material here is actually a texture on the model or on a wall of the map. Yeah, it will build the file name using this function to get the file name on the disk, and then it uses this function to build the absolute path of the file, and then go shell execute on the absolute path to edit the file with the register editor. But normally if this one if the file passed into the shell execute is a script file like a PowerShell script or a VBS script, it allow us to achieve code execution. So how is this exploitable? Well, we can see that the buffer size is only 256, but in Windows the maximum pass length is 260 characters. So how do we exploit? We prepare two files, a very long file with .speed1.vmt with absolute path length equal to 259. So it fit in a buffer of 260 with null character at the end. The reason why we have to prepare this file too, because the engine at first it will load this file. If it cannot be found, then the texture will not be loaded and it will be replaced with a placeholder materials, and we will fail. We cannot exploit it, and we prepare another file without the VMT extension with absolute path length equal to 255 because we stream down the VMT extension 4 characters. So as we know before, the buffer size that we fit into SN printf is only 256, and of course with with this file name, it will not include the BMT extension into the final buffer. Then at the shell execute stage, it will essentially call our this1 file and we get shell. This one is also displayed on H1 544096. This one is lame bug. Then I think in terms of exploitable, I think logic bugs are beautiful and have much more potential than memory corruption bug, because with logic bugs, you usually don't have to chain it with the info leak, so it's pretty easier to exploit. Like example like this one, I don't have to bypass any mitigation like ASLR or something like that. I just put the file in place and I get code execution. So, and I found their server tries using logic bugs, but they still haven't resolved them, so I cannot talk here. These bugs are cooler than this bug, I swear. Well, sadly, 6 months already. Well, next thing, after those example, I will talk about the exploitation strategy. Well, generally, at first they don't require full chains for the report to be valid. Back then in 2018, someone just submit a stack of flow and they give them like $10,000. Well, then they require full chains for the report to be valid, and they only give out like 7.5K now. Fortunately, they allow one info leak bug to be used in multiple reports. So if you find multiple overflow bugs, multiple write overflow bugs, you can use just one info leak to exploit all those write bugs. And also in 2020, CSGO still use the xinput 100-3.dll, which doesn't support ASLR. So I know many researchers use this DLL to build their exploit. At that time, I don't really find any info leaks. So most of my bugs submitted to the program are logic bugs. And until now, logic bugs still dominant in my report history. I'm noob, so I cannot defeat ASLR in these games. Leaking in this software and game are so hard because unlike normal CTF challenges, you get pipe to the STD in and STD out. There are many things you can do if you apply directly to the program, but this one in networking, they only send us things related to the game, so we have to read a lot to understand the networking code, the logic behind it, so we can spot where we can leak the pointers, so we can defeat ASLR. It's pretty. In conclusion, the hardest thing in exploiting memory corruption bug in soft engine is finding an info leak bug. Well, the last thing I want to talk here is the state of the bug bounty program of Valve. They doesn't really care about client-side bugs. They usually they respond pretty quick if it's a Steam bug or it's a server bug. But my latest server bug, they still haven't replied. At first, they gave simple crash 10Ks and more. Then they only accept full chain, and then now they don't bother fixing it in time anymore. Also, HackerOne triangles are slow to try my reports. Some some take them over a month to like just reproduce the bugs pretty long. So and CSGO get updates like bi-weekly, no, like weekly or 2 weeks between updates. So I have to update obsess all the time. Pretty frustrating. So I stopped finding bugs in search engine already. I moved to other targets. Goodbye. Yeah. Well, that was my presentation. Here, let's begin our Q&A session. And before that, our team are hiring SecOps engineer, security engineer, software engineer, and project manager. If you are interested in the career at C, visit the link here, security.c.com, for more information about our team. Thank you for attending my talk. If you have any question, raise your hand and ask now.
If you all can have question, can just type in the chat also.
Yeah, no need to raise your voice. I know we engineer are introvert. We don't want to raise our voice.
Again, that's his Twitter handle. Thanks again for the talk. Wish you good luck in ranking up in CSGO. And, yeah. For the next portion, right, will be the mini CTF. Jinhua, if you're ready, I can pass the time over to you. But before that, let me just post some links. Yeah, since you'll be the MC for the next part, I'll just post the usual links to the sort of sponsors, security technologies and advanced research lab, as well as Kala Tech. Then the link for the networking at Gathertown later tonight, as well as the feedback form. So if you fill that up, you can stand a chance to win $10 Grab food vouchers. Yeah, that's it for my part. Then, oh yeah, thank you, Vin. Okay, see you. Thank you. Yeah, so maybe, okay, I can pass the time over to Jinhua now for the mini CTF.
Okay, thanks, Nigel. Let me just share screen first. Okay, so hi guys. Now it's the mini CTF. Before we start the CTF, I'll just go through some rules and like what's gonna happen and everything. So the timeline will be 5 minutes introduction, which is what we're doing now, followed by 30 minutes of CTF playtime. And after all of those, we'll have a solution walkthrough after that. For the solution walkthrough part, it might drag a little bit, so you don't have to stay all the way if you can't. So ground rules, okay, just the normal stuff. Don't abuse the server. All the flags in the CTF is in the form of SecWed curly brace with the string in the middle. Do not attempt or promote any execution of any scans on the CTFD platform. There's nothing on the CTFD platform. Just the challenge. Just go to the challenge and do it. Don't attack the server. Then don't use any glitches, hacks, or bugs that will cause an incident within the community and affect other players. Part 2, not allowed to brute force any flags on the platform. No sharing of flags and hints across the teams or any duration of this competition. If there are any bugs that you found, right, please report them immediately. You can just PM any of us, like me, Daniel, Kelzin, Akash. Yeah, do not attempt to DDoS our servers also. If there are any issues, please PM us. And remember to register with your NS email to be eligible for prizes. Okay, so what are the prizes, right? Later I'll go through them after I go through the challenge. Okay, so first we have web challenges. We have one web challenge, one crypto challenge, and one phone challenge. So for the prizes, for each of the challenge, we reward the first 3 person who solve like each of the challenge. So first 3 for web, first 3 for phone, first 3 for crypto. So maximum 1 voucher for each winner lah. So you cannot take all 3 lah. And there are no extra prizes for the overall winner. So let the games begin. Okay, the link I'll send in the chat. May the best man or woman win. Let me know if you have any questions. You can just type it out or ask. So we'll be going through the web one first. So for the web one, right, it's about a Python CVE, is 2021-3177. So from Python 3.x to 3.9, there's a buffer overflow. So it might lead to RCE in certain Python applications. Yeah, and in the CV itself, it actually mentions the payload 1E300. And this happens because the SPNF is used unsafely. So what actually happens, also on the left-hand side, you see the code, right? So the car buffer is actually of size 256. So in this particular case, where the tag of the Python string is a D, which stands for double, what this does is it uses SPNF, the SPNF to the buffer, %C and %F. So the C is the tag, so that one's not so important. But the %F, so using %F with a double, right, is a bit dangerous. Because the maximum character that can be represented with a double is around 230 something characters, which is more than the buffer. So so what happens is that you just need to send this payload to the server. Anything that's more than like a bit more than 256, right, will crash the server. But actual RCE is hard to exploit because of the stack protections, ASLR, Canaries, etc. Yeah. So just run this script and get the flag. Yep. So next I pass to Akash.
Okay, guys. So for the pawn is actually pretty simple. So this program basically gives you a chance to enter your name. After that, it will read in your option in whatever option you enter in a loop. So the option is 1 is for echo, 2 is for who am I, and 3 for execute. So if you read the source code, obviously you want to run execute because your aim is to read out the flag. So you just want to run execute. But the thing is, right, upon your initialization, right, you're actually considered a normal type user. So you need to sort of like make yourself an admin user. So the way to do that is to use this overflow in gets. So if you guys didn't know, right, gets will read unlimited number of characters until it reads a new line. So what we can do is, since we read in the user.name, right, which is me.name, right, you enter in 0x20 or 32 characters. And after that, you enter in the integer representation of the admin, which is 1. So once you do that, right, you will be considered, when it checks your admin field, me.type field, right, you will be considered that you are an admin type instead of a normal type. Yeah. So next slide. So yeah, same as before, just fill up your name buffer with 0x20 characters. After that, you have to give your value of 1 as integer representation. Make sure it's in the proper endianness. Then after that, just use your option 3, execute. And after that, you just need to enter your command after and just like cat flag.txt. Yep, that's all. So the flag is just, okay, maybe not cute.
Okay, so I will be presenting the crypto solution. Okay, give me a moment. Yeah. Okay, so this crypto question is very interesting. So basically what you have is like you have this this tree A, B. You got what? You got okay, never mind, let me just get my pen out. Okay. Yeah, so you got like the flag, right? So the flag is here, and then the flag is split into 3 parts. So these are the 3 parts of flag, and then it's represented as X, Y, Z. And then so the question only gives you the P, which is the modulus, and then A1, A2, and A3. So this A1 is X takes to the power of 2, Y takes to the power of 2, 3 takes to the power of 2, and then modulo, and so on. Yeah, so it looks very complicated, but then we can actually just do something like this. Okay, yeah, so if we simplify the equation into something like this, then we just, what we want to do is we want to solve this equation. So we got A1, A2, A3, and then we want to find X, Y, Z with P is known. How do we do it? Yes, we can do it using Sage. So if we write F1 into something like this, F2 into something like this, F3 into something like this, we can use Sage math. So Sage have a function called resultant, and this resultant will basically combine F1 and F3 and remove the Y variable from F1 and F3. So yeah, and by that we can get a G1. So this G1 is a resultant of F1 and F3. G2 is a resultant of F2 and F1 and F2. So this combining these two, it means that this G1 and G2 will not have the variable Y. And then I just combine these two together again, and I'll get G3, which only contains the equation X with one variable X. So this is the answer. And yeah, basically is the same thing. Like F1 resultant F2Y, F1 then resultant F1 resultant F3Y. And okay, maybe I do some annotation. Okay. So from here, Y is removed. Here, Y is removed. And then this whole thing will remove X. So this F will represented in Z to some power plus Z to some power and all that. And then if we get a univariate polynomial, we can just find the roots using Sage, and this is the solution. Yeah. So if you want to learn more about this, I actually in one of the Security Wednesday session, I have talked about this kind of equation, which is called the Diophantine equation, and it's literally the same thing. Okay. Yeah.
Okay, so if you want to try these challenges again, they are available on our GitHub repo. I will send the link in the chat now. Oh yeah, Daniel sent the link in the chat already. I think I sent the wrong one. Okay, anyway, here are the winners. So from Pone, the first place is Stitz. Because Biden the one his like price. So first one is Stitz, then second one is 1010, third one is Spacewalker. For web, first one is Jingyan, second one is Erythro, third one is ASDFG. RIP for crypto lah. Okay, so that's all. Let us know if you have any questions. The winners will be contacted through their email later.